Good morning, good afternoon, or good evening, depending on when you are watching, and welcome to the Virtual Math Network, your main source for 5th grade math education. Today, we are looking at the volume of prisms, which is Unit 6, Module 3, Session 4. Let's get started. First of all, to study the volume of prisms, we have to know what a prism is. A prism is a three-dimensional shape like the ones you see on the screen, with identical ends called bases and flat sides called faces. Prisms come in many different shapes, but for now, in 5th grade, we will be studying rectangular prisms. Here on the side of the screen, you see we have a triangular prism. This is a hexagonal prism, and down here, right behind my face, is a rectangular prism, much like the ones we've seen in the past. Here's some good news for you. We've actually already studied rectangular prisms quite a bit this year, including the boxes for Brad's baseballs. So hopefully this will be a little bit of a review for you, or you'll pick it up in a jiffy. The volume of rectangular prisms, as we have talked about in the past, is found by multiplying the length times the width times the height. So taking a look, let's take a look. Length, width, and height are a little bit, it depends on your perspective of the prism. So some people like to ask, how do I know for sure which is the height, which is the width, and which is the length? Well, more good news for you. First of all, multiplication is commutative, which means as long as we are multiplying all of the numbers together, it doesn't matter what the numbers are, we can do it in any order we want. In fact, earlier in the year, we talked about strategies of multiplying the numbers that worked better for us to multiply first, and then the harder ones second, so that it made it easier to multiply in our heads. So for example, if I have a problem 3 times 5 times 10, it's really the same as 5 times 10 times 3, or 10 times 5 times 3. No matter what, I'll get an answer of 150, no matter which way I multiply it. Second of all, prisms depend on perspective. Depends on really how you're looking at them, right? A box can look different depending on which way you look at it or which way it is laying down. So, taking a look at some examples here, these two boxes are the same. One of them has been turned on its side, or the one box has been turned on its side so that it looks differently, but in fact, they are the same box and have the same volume. For more on that, let's go to our correspondent, Nate, who is out in the field.
Yes, that's right, Nate. I am out here in the field where we have discovered this rectangular prism that we've measured and found it to be 13 by 20 by 3 inches, making for a volume of 780 inches cubed. Now, we have also found that upon turning this rectangular prism upright, that it does actually look different. However, it is still the same box, and it still has the measurements of 13 by 20 by 3, thereby still having the same volume of 780 inches cubed, proving that you are correct back in studio that orientation affects the way it looks, but it does not affect the volume of the rectangular prism. Back to you, Nate.
Thank you, Nate, for that great report out in the field. So, I think based on what we know, Armagard, math is awesomer than I already even knew. Let's try it out, shall we? We are looking to find the volume of this particular rectangular prism. So remember, length times width times height. It doesn't matter which order you do it in. Doesn't matter if you flip the box on its side, or its head, or its back. Length times width times height. As long as you are finding one measurement in 3 different directions, you are going to be good to go. So in this case, we can do 10 times 3 times 4, or 4 times 3 times 10, or 3 times 10 times 4, or whatever combination of those 3 numbers you can think of. Let's find out. In any case, we multiply to get an answer of 120. That's our numerical answer, though. We still need a label. So the label we use depends on the units we are measuring in. In this case, we are measuring in inches. So the answer would be 120 inches then, right? Well, close, but not exactly. We need to take into account that we have 3 different measurements, 3 different dimensions for this measurement, in fact. So we need to express that in our answer. If we were to simply say 120 inches, that would mean a length of 120 inches. If we were to say 120 inches squared, it would mean that we were talking about a 2-dimensional figure. But since we have 3 dimensions, we need to include an exponent of 3 after our label to show that this is a measurement of volume. And along with this, we use the word cubed. So for example, our answer here is 120 inches cubed. 4 inches times 10 inches times 3 inches is 120 inches cubed. There's that exponent of the 3 that I was talking about. Notice that it is an exponent because it has been lifted up or raised up a little bit. It is not the size of the other numbers. We want to work on that as we are writing our labels as well. So a couple extra practice problems for you guys, and then off you go. Why don't we give those a try? Take a moment, write them down in your math notebook, and then we'll answer them to see how we did. All right, hopefully you've taken a moment, paused the video. We're coming back to take a look. Let's take a look at our first rectangular prism on the left, outlined in red. That prism is 5 centimeters by 7 centimeters by 2 centimeters. When we multiply those together, we can use any order of the numbers that we want. I like the idea of multiplying the 5 and the 2 first, because that makes 10. That's nice and easy to work with. And then 10 times 7 gives me 70 centimeters cubed. Notice that I'm using the label of centimeters and that it is cubed here in the end. Okay. Our blue one, 13 times 3 times 2, or 2 times 3 times 13, or whichever order of numbers you'd like to multiply in, we get 78 inches squared. And the last one, 2 feet by 3 feet by 6 feet gives us an answer of 36 feet squared. So on to your work for today. Your responsibilities include student book page 240, Seesaw Post and Home Connection pages 125 and 126. So that is all the time we have for today on the Virtual Math Network. I look forward to seeing each and every one of you tomorrow. Have a great afternoon. Have a great evening. Whatever it might be, whatever time it is, enjoy it and enjoy your weekend.